So this is Algebra 2, 4.7. We're going to be transforming exponential and logarithmic functions. And we've already been transforming throughout this book, so this will be some review, but in terms of exponentials and logarithms. And Lee and Sal are having their conversation there. Lee, we need to stretch the exponential function, and she says it looks stretched enough already. Okay, psychologists use transformations to I kind of wonder if they really do. Maybe the ones that are writing the textbooks use transformations. I don't know that the psychologists are sitting down there doing math, but some of them maybe are. Okay, so on this slide, let's review a little bit what these transformations are that we've learned about. So let's say, and we'll do these in terms of exponential. So let's say we had y equals 2 to the x minus 1. What would that do to the graph? Well, first of all, what's the parent graph? Well, the parent graph would be y equals 2 to the x. I'll fix that. So the parent, just as this quick review, is y equals 2 to the x. And then the minus 1 is, since it's on the outside, that's going to move it down 1. And if it was a plus, it would move it up. Okay, what about if you had the same parent function, 2 to the x, but this time it was x minus 7? Well, since the minus 7 is with the x, that's going to be back and forth movement. And it moves in the opposite direction of the sign, so this would actually move to the right 7 units. And then how about we had the same parent function, but this time there's a negative out front. Okay, that's going to be a reflection, and that one's going to reflect over the x-axis. In order to reflect it over the y-axis, where would the negative go? And if you said with the x, you would be right. So that's what it'll look like if you're reflecting over the y-axis. And then we had our stretches and compressions. So if we had y equals, let's put a 3 out front, something like that, when the parent is still 2 to the x, but the 3 out in front, that's going to be a vertical stretch. It's vertical because it's out front. It's a stretch because 3 is greater than 1. And if it had been a fraction like 1/2, it's still out front, so that's still a vertical, but it's going to be a compression since the half is less than 1. And then on the other hand, if we had y equals 2 to the 3x, the 3 is up there with the x, so that's going to be a horizontal, and we have to be careful with the horizontal ones. They are the reciprocal, so it's actually like 1/3, so it's actually a compression of 1/3. Those are the tricky ones. And then if you had a fraction like 1/3 x, because it's with the x, it's still a horizontal change, but in this case, it's the reciprocal of 1/3, which is 3, so that's going to be a horizontal stretch of 3. Okay, I guess I should have said on this one vertical stretch of 3, and this was a vertical compression of 1/2. By a factor of 1/2 is how we usually write that out. Okay, so I just want to make sure I didn't miss anything. We talked about reflections. So you're going to have shifting left and right, shifting up and down, reflecting over x and y axis, and then vertical stretches and compressions and horizontal stretches and compressions. So these are some examples of what they look like with exponential functions. You can look on page 281 if you want. There's a nice chart there if you want more information about this. So now we're going to utilize the information and do some graphing. So first of all, we see that we have g of x equals 2 to the x minus 4, and you want to first of all identify the parent function. So that's 2 to the x. And I'm going to do mine a little differently. What I'm going to do is I'm going to graph 2 to the x because that's something I can graph pretty quickly, pretty easily. and then I'm going to transform it. So if I do 2 to the x, this is 2 to the negative 2, which is 1 over 4. This one would be 2 to the negative 1, which is 1 over 2 to the 1, or 1 over 2. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8. I'll try to draw a fairly nice graph. So I'm graphing the parent, because I want to utilize transformations to graph g of x. Back 2 up a fourth, back 2 up a half, 0, 1, 1, 2, and then 2, 4, 1, 2, 3, 4, and that's good enough to get the feel of it. There's 2 to the x. I also want us to graph the asymptote, so I would like you to do that as well when you're graphing these. Please draw in the asymptote with a dashed line. And then in a different color, I'm going to transform the 2 to the x. So I look at my g of x, and it is it's minus 4 outside the function, so that's going to be an up or down, and it's going to be down 4 units. So I am simply going to go to my graph, and I'm going to move every single point down 4 units. And the easiest, well, first let's move the asymptote down 4. 1, 2, 3, 4. Please move your asymptotes. Show your asymptotes and move them if they need to be moved. So this point 0, 1, I'm going to simply count down 4 units. 1, 2, 3, 4. This point here, I'm going to count down 1, 2, 3, 4. This point down 1, 2, 3, 4. And that's good enough. I don't even know. I can move these down 4 too. 1, 2, 3, 4. And you know that these are going to be close to the axis, or to that asymptote. So this is 2 to the x minus 4. So it said describe the asymptote. Oh, so the new asymptote, you can just abbreviate, is y equals negative 4 now. It was 0. It has moved down to negative 4. Tell how the graph is transformed. So we did that. It's down 4 units. And then here's our graph. This is how I would like you to do them as well on the homework. And here's one for you to try on your own. And then you can come to the tape and I'll be doing it, or the video. Make a table of values and graph 2 to the x minus 2. So identify your parent, which is 2 to the x. We just graphed that on the other one, so I'm going to graph it again. Instead of making a new t-chart, I already know what the values are, but you can look back in the t-chart we just made on the previous slide. So I'm graphing the parent right now. I know that it goes through 0, 1, 1, 2, 2, 4, negative 1 1/2, negative 2 1/4. That's 2 to the x. I'll get a different color and we'll dash in our asymptote. So there's our parent. Now a new color. So now let's look at it. Describe how the graph is transformed. So j of x, so I've got 2 to the x minus 2. The minus 2 is up with the x, so I know that's going to be a horizontal, and it's going to be in the opposite direction of the sign. So since it's minus 2, it's actually going to be to the right 2. So my asymptote is going to move right 2, but so it's not moving up and down. So the asymptote's going to be the same. It's not going to change. If you move your asymptote right 2 and it's a horizontal line, it's not going to go anywhere. So the asymptote stays the same. I'll make a note of that. The asymptote is still y equals 0. And then every point on my parent is going to move to the right 2 units. So I'm simply going to count over 2 units. And that's good enough. And there's 2 to the x minus 2. And we've completed the objectives on that one. I don't like orange and green together. They look gross. Okay, so again, so now we're doing stretches and compressions. So these are a little more challenging than moving things left and right and up and down. Okay, again, I'm going to graph the parent. So the parent is the one with the base. The 3 to the x is the parent. Okay, to graph that, now I'll admit it, there's a quick little way to graph these. Is just using 0 and 1. We could use 2, I guess, 2 if we want to. So 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9. And if you know what they look like, I mean, I'll do -1 too, why not? 3 to the -1 is 1/3. I think 4 points is sufficient. Okay, so -1 is up 1/3, 0, 1, 1, 3, and 2, 9 is way up here somewhere. So I'm not even going to bother to graph that real perfectly. There's 3 to the x. That's your parent. So when you're doing these, please graph the parent, because I want you to graph these in the spirit of the transformation. That's the whole point of this lesson, as opposed to just blindly plotting points. And I'm also going to put in my asymptote, which is still y equals 0 for the parent. Now do boring black. Okay, so the transformation, you have a 2 out in front. Because it's out in front, it's going to be vertical. And verticals are very straightforward. Since the 2 is greater than 1, it's going to be a vertical stretch by a factor of 2. So because it's a vertical stretch, then the y coordinates are going to be changed. They're going to be multiplied by 2. So what I can do in my t-chart here is I can make a little new column for g of x equals 2 to the 3x. My x's are still the same. I'm multiplying my y's by 2. So 1/3 times 2 is 2/3. 1 times 2 is 2. 3 times 2 is 6. And 9 times 2 is 18. So I'm still going to be working with the point -1 is my x, and I'm going up to 2/3 this time. 0 is going to be 2. 1 is going to be 6. 1, 2, 3, 4, 5, 6. And 2 is 18. It's way up there. Really steep. So that is g of x equals 2 times 3 to the x. And make sure it looks like it's doing what you would expect. That definitely looks like a vertical stretch. Notice the asymptote. It doesn't change with vertical stretches. So the asymptote is still y equals 0. It does say find the y-intercept, so that we already know. The y-intercept is 0, 2. So we need to identify that. We got the asymptote, y equals 0. We described how it's transformed here. And we drew the graph. So we did everything. Okay, you might try this next one on your own. So I always start with the graph for some reason. I'm going to graph the parent first, so it's 2 to the x again. So when you're finding your parent, you're looking for the exponent and the base. The base is 2, so it's an exponential. It's just going to be 2 to the x. And we've graphed that a couple times today already, so I already know those points, and you know them too from your table. -2 is 1/4, -1 is 1/2, 0, 1, 1, 2, and 2 is 4. That's the parent, 2 to the x. And let's put its asymptote in there too. Okay, please start by graphing the parent. Then identify the transformation. So on this one, there's 2 transformations. There's a negative out front, so that's going to be a reflection. And when it's out front, it's going to be a reflection over the x-axis. And then there's a 1/4 out front, so that's also a vertical. And in this case, it's 1/4, which is less than 1, so it's going to be a vertical compression by 1/4. You know what? I am going to need my my t-chart so I can find my new y values, come to think of it. X, this is going to be my parent 2 to the x. So we've worked with these a bit already. We know that that's 1/4, 1/2, 0, 1, 2, 4. Okay, so now let's go ahead and reflect it over the x-axis first. So I'll do that in pink. So I'm simply just going to, when you reflect the point, it goes perpendicular, like this, along the perpendicular to this axis, and it's in the same distance above. You go the same distance below, so that they're perfect reflections. This will be -4, 1, 2, 3. Okay. So that's kind of the intermediate. That's an intermediate step. So I could do that here too, the -2 to the x. All the y values are going to change sign. So that's all I did. I changed the sign on every y value. Then, I know this is a long process, but it's good for you to see how the transformations work. Then we're going to do -1/4 of 2x. 2 to the x, I mean. So you're going to be multiplying the y's, these new y's here, by 1/4. So 1/4 times that is 1/16. 1/4 of that one is 1/8. 1/4 of that one is 1/4. 1/4 of that one is 1/2, and 1/4 of that one is 1. And these are all still negative. Okay, so we can finally do our final graph. -2 is -1/16, so it's very close. -1 is -1/8, very close as well. 0 is -1/4. 1 is -1/2, and 2 is -1. And that's the final one, h of x. And so let's look at it and make sure it makes sense. Yeah, clearly it was reflected over the x-axis. And since it's a vertical compression, yeah, it should be flatter, and it is. And then we need the y-intercept. So the new y-intercept, we already know it. It's 0, -1. I'll check it. Yeah, 1/4. And the asymptote is still the same. We didn't shift up or down. So the only time your horizontal asymptote is going to change is if you shift up or down. So it's still y equals 0 is the asymptote. And we described our transformations. There are 2 of them here in blue. And so we're good to go. You can also check this on the calculator, especially the harder ones. If you're not sure about them, it's a good idea to check them. So I'm going to just type in -1/4. I can type that in as 0.25, parenthesis 2 raised to the x. Let's do a zoom 6. Okay, looks pretty close to what I have there. You can also go to y equals and put in 2 to the x to compare it to the standard, to the parent. So those look similar to what I have on the graph there. Okay, so these are some you can definitely do on your own. Okay, so the parent is 5 to the x. And the 1/3 out front is, it's out front, so it's vertical. And since it's less than 1, it's a vertical compression. So this one, since it's just one transformation, it shouldn't take too long to do. I'll try to do these somewhat quickly too, since you've had time to do them on your own. Hopefully you've done that. X, and this is just going to be the parent. I'm going to just do -1, 0, 1, 2. So that's going to be 1/5, 1, 5, and 5 squared is 25. -1 up 1/5, 0, 1, over 1 up 5, 1, 2, 3, 4, 5. And that's about all I'm going to get graphed on there. So there's your parent. Y equals 0 is the asymptote. And then it's going to be a vertical compression by a third. So I need to multiply, since it's vertical, all my y's by a third. So a third times that's 1/15. A third times that is 1/3. A third times that is 5/3. And a third times that is 25/3. So I'm at -1, 1/15. That's really tiny, so it's real close. 0, 1/3, about a third of the way up. 5/3 is the same as 1 2/3. So over 1 and up 1 2/3. 25/3 is the same as, let's see, 3 goes into 25 8 times with a remainder of 1. So 8 1/3. Over 2 and up 8 1/3. 1, 2, 3, 4, 5, 6, 7, 8 1/3. So somewhere up there. So this is, oh, that's kind of interesting. I was going to say, did it look like a horizontal? Well, this is probably graphed very nicely. Probably maybe it should be over there. Anyway, the main thing is right in here you can see that it did get, the blue curve has been compressed vertically. And again, so the asymptote's going to stay the same. And the new intercept is 0 1/3. And we described the transformation here, vertical compression by 1/3. Okay, next one. So the parent is 2 to the x, rather. X, and then the parent, I'll do the parent here. We've worked with this a lot now. I almost am doing it without even thinking. 0, 1, 1, 2, 2, 4. It's kind of by memorization almost there. That's one thing. If you repeat these problems enough and spend the time, if you put the time in and do these problems, it's going to stick better. You have a better chance of it sticking with you. Back 2 up a fourth, back 1 up a half, 0, 1, 1, 2, 2, 4. See, this is graphing 2 to the x has just like almost become rote. Don't even have to hardly think about it if you do enough of these. So there's two transformations. There's a negative with the x. So because it's with the x, it's going to be a horizontal reflection. So in other words, it's going to reflect over the y-axis. And the 2 out front is a vertical stretch by 2. Okay, so if we reflect over the y first, everything that's on the right or the left-hand side will reflect over to the right-hand side. And everything on the right-hand side will reflect over to the left-hand side. And they reflect. The same distance from here to here will be the same as from here to here. So this is 2 to the negative x. And then you're going to be multiplying every y coordinate by 2. So if you multiply, I'll make a new chart here. Let's do a different color. We can do this nice. I like pink for some reason. This is 2 times 2 to the negative x. Oh, I forgot to do the negative x. Well, on these, boy, do we want to take the time to make this really pretty, or should we just kind of do it? The y's are going to stay. Oh, no. Yeah. So the 2, you have to multiply the y's by 2. So this is times 2, so that's going to be 1/2. This is times 2, that's 1. Times 2 is 2. Times 2 is 4. Times 2 is 8. But the difference is that these x's are now actually different in sign as well, because when you do a horizontal one, your x's are going to change. So I'm moving the orange curve, and my x's are actually opposite. I know this is probably a little confusing. I know you're thinking, why not just do this on a calculator? And it would be a lot faster on a calculator. These are the new x's. Since I had to reflect, my x's have changed. So now, if I go over 2, I'm graphing the pink ones. I'm going to be going up 1/2. if I'm going over 1, I'm going to go up 1, 0, I'm using the pink, so 0, 2, -1, 4, and -2, 8 is way up here somewhere. So the pink ones are my final ones. That's 2 to the 2, or 2 times 2 to the negative(x). And you can see it is a vertical stretch. It did stretch up from the parent function, and it was reflected over the y-axis. So the new y-intercept is 0, 2. That's this one right here. And the asymptote stayed the same. And then we've got our transformations right here. It is a lengthy process, but it does work, and you can see how the transformations work. Okay, now guess what? We get to do it all over again. Wow, time is speeding by with logarithms. I'm probably going to make this into two videos, one for the graphing and then one for the other part of it. So let's do right now let's do logarithms. So say, and I'm going to do these. So say you had y equals log of x minus 4. Okay, because the minus 4 is outside, that's going to be a up and down, so it's going to be down 4 units, so it's a translation down 4. If I had log of, let's do log base 2 just for fun, of x minus 3, because the minus 3 is inside the parentheses with the x, that's going to be a back and forth shift in the opposite direction of the sign, so it's actually going to go right 3. If I have a negative out front, let's do negative natural log of x. So that's because it's out front, it's going to be reflection over the x-axis. So these transformations are all the same, it's just with logs now instead of exponentials. And if I have log base 4 of negative x, because it's inside with the x, that's going to reflect over the y-axis. And if I have the number multiplied out front, like 3 log base 4 of x, that's going to be a vertical stretch because it's out front and it's greater than 1. 3. If it was a fraction, it would be like if it was 1/3 log base 4, that would be a vertical compression of 1/3. So we've done back and forth, up and down, reflections, and vertical stretches and compressions. That leaves us with the horizontal stretches and compressions, and those are inside with the x. So that would be like y equals log of 3x. So that 3, because you have to be so careful with these ones, this is a horizontal, and it's actually 1 over b, like think of this as the b. So it's actually 1/3, so it's a horizontal compression by 1/3. And if it was natural log of 1/2 x, that's going to be horizontal because it's in with the x, but it's the reciprocal of 1/2, which is 2, which makes it a stretch. So it's the horizontal stretch by a factor of 2. And this chart is on page 282 if you want to look at it further or write any of it down, because they have it written in a couple different forms there. And on all these I chose different log bases just for fun. So when you're finding your parent, it's going to be log of whatever that base is. Like this one right here would be log base 2 of x would be the parent. This one would be y equals natural log of x would be the parent. Okay, so now we get to go through and we have to graph all these, kind of like we did with the exponentials. So first of all, I'm going to graph the parent, which is just natural log of x. So I identify the natural log and I just put x there. I leave everything else off. I want it as simple as possible. In order to graph natural log of x by hand, the quick way, first of all, you need to know what logarithms look like. All logarithms, the parent functions of all logs, go through 1, 0, and they have this basic shape. That basic shape. okay, you know, how steep, how big, or like they'll vary a little bit based on the base, but this is the basic shape. So if you know that basic shape, you can graph any logarithm, you know, just sketch it out. So in this case, if I'm just graphing these by hand, which you can do as long as you know the basic shape, this is log base e, natural log is log base e. The two values you can use for your x are 1 and whatever the base is. The base is e for natural log. So you can use 1 and the base. So what's the natural log of 1? Well, that's 0. What's the natural log of e? That's 1. So I can plot these 2 points. You do have to know what e is. It's 2.71828, granted. So the point 10 is on my graph, and the point 2.71. So I'm going to go over 2.7 and up 1. And then I know the shape. I know that x equals 0 is my asymptote. And I know it's going to approach that, and it's going to curve and look like that. And I can just graph it using those 2 points. That's just the quick sketch, and you believe me, as you know, I mean, graphing these by hand, you want to be as quick as you can. Great, so there's our parent function. Then we look at our transformations. We've got a negative out front, so that's a reflection over the x-axis. And we also have a -4 inside with the x, so that's going to be a back and forth movement in the opposite direction. So it's, since it's -4, it's actually going to the right 4. So I only have 2 points to work with, so this shouldn't take too long. So first I'm going to reflect over the x-axis. So this point's going to stay on the x-axis. And if I reflect this one over the x, it's going to come down an equal distant on the other side. And then so I'm going to have that. That's negative natural log of x. And then I have to move it to the right 4, so I am simply going to move my 2 points and the asymptote, by the way. Let's move the asymptote to the right 4 as well. So I'll go to orange. So I'm going to move my asymptote over, 1, 2, 3, 4. I'm going to move each of my blue points over 4. So this one, 1, 2, 3, 4. And this one's going to be a little harder. 1, 2, 3, 4. And I know now it's approaching this orange asymptote. And then it's done. That's actually not too bad. Let's graph it on the calculator real quick to make sure we did it correctly. Y equals clear, clear. So negative natural log of x minus 4 graph. 1, 2, 3, 4, 5. Yeah, you can see at 4 here. This is at 4. There's your horizontal, or your vertical asymptote. You can see it crossing right there. That's kind of way. Yeah, right there. Yeah, 1, 2, 3, 4, 5. So it looks good. Graph the log. Find the asymptote. Okay, the new asymptote is 1, 2, 3. X equals 4. Then describe how the graph is transformed. We did that. Here's our description. Okay, next, let's do it again. This time we have log of x. So you first identify the parent. The parent is y equals log of x. You just want the bare bones equation there. So what's the base of this logarithm? It's 10. So if I want to graph this, I'm going to use 1 and I'm going to use the base. So that's the base, and then 1. Log of 1 is 0. Log of 10 is 1. See how I can do that pretty quickly in my head if I use those two simple ones. I know the shape of a logarithm, and you should too. Make that your goal, to know what these look like. So just the basic logarithm has this as its asymptote. I'm going to plot the point 1, 0, and the point 10, 10, 1. Darn, it's way over there. Shoot. Oh, do I want to redraw it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. It's going to be a pretty, I'm just going to sketch it. Whoops. It's going to be really flat. That's good enough for now. I don't want to take the time to erase it and redraw it. You'll have to just use your imagination. Log of x is a lot flatter than natural log of x. Okay, now our transformations. So we have a 3 multiplied out front. That means it's going to be vertical stretch of 3. And then everything is shifted up 5. So if I want to do my vertical stretch here, I'm going to do it in this column. That means I need to multiply my y's by 3. So the 0 times 3 is still 0, and then 1 times 3 is 3. So I'm going to I should really redraw this thing. You know, I think I will, because I need to move. I'll just draw it over here. I need to move those points. And I know the basic shape. Five, 6, 7, 8, 9, 10. Okay, they don't care about those. So, asymptote here. 1, 0, 10, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. And we know it is shaped like so, and it's very flat. That's the parent. Then after I stretch it, I'm going to have the point 1, 0. That doesn't change. And then 10, 3. So over 10, I'm going to now be stretched up to 3. 1, 2, 3. And the asymptote stays the same with that stretch. Oops, I kind of missed, but anyway. So this is 3 log of x. Then all I have to do is move everything up 5. So this point will go up, new color. 1, 2, 3, 4, 5. And this point will go up 5. 1, 2, 3, 4, 5. And the asymptote still stays the same. So this is this flesh-colored one is the final one. I'm gonna get a feel while we've got. Okay, so we have one more of these. We'll do that now, and then I'm gonna stop the video. Graph the log function p of x, and hopefully try this on your own first. Okay, so first we're going to identify the parent. That's the log, natural log in this case. Natural log of x is the parent. So I'm going to make my little t-chart. And the easiest thing you do, you use 1 and use the base. The base of natural log is e. So here you do the natural log of 1, which is 0, the natural log of e, which is 1. And I've got lots of room, so I can make a nice graph. Okay, 1, 0, and E is 2.7 up 1. And I know it approaches this vertical asymptote. There's natural log of x. Then I look and I decide what my transformations are. So I've got a negative out front. That's going to be a reflection over the x-axis. I've got a +1 inside with the x. That's going to be a back and forth in the opposite direction, so it's going to be left 1. And then I've got a -2 outside, so that's going to be down. That's down 2. Okay, so let's go ahead and reflect it over the x-axis. Here's the x-axis. So this point will stay where it's at, and this one's going to come down the same distance, but on the other side. Draw the new graph. So there's the reflection of natural log. And then we're going to move it left 1 and down 2. You can actually do that all at once. I think I will. Let's do green. So let's take each point and move them left 1. So I'm going to go back 1 and then down 2. I'm going to go back 1, that's about to there, and down 1, 2. And my asymptote is also going to go left 1. It's important to draw in the new asymptote. And so then, once I have that, I can see, I know my shape is like so. And I always step back and look at it and make sure it did what I thought. It's definitely a reflection. It went back and down. And you can also graph it on the calculator. So, oh, and make a note of the new asymptote. It's x equals -1. I was noticing in the book when I was looking at this, actually, let me see. Oh, yeah, that's good. So we can stop there, and I'm going to do a shorter video for the rest of this. Well, you know, I might be able to fit it in. What's going to happen is the bell's going to ring here in about 10 minutes. I think we'll do 2 just to make it easier for you.